plus y squared is r squared defines our circle. So I've got a circle here. Let's write the equation of this circle. I like to note where its center is. This is nicely centered at 0, 0. So what's the r? What's the radius? What's the radius? 3. And how did you figure that out? You can count boxes, right? 1, 2, 3. You can see them. 1, 2, 3. You pick this one. You can, but now you got to use the distance formula. So why not pick an easy one, either a horizontal or vertical axis? Great. So what's the equation? If x squared plus y squared is r squared, what's the equation? What's r squared? 9. X squared plus y squared is 9. It's that simple. Oh, sure it is. No, it is. It's that simple. Circle centered at 0, x squared plus y squared is r squared. Find that radius, square it, you've got an equation. And that's it. Sure, yeah, what's the catch? Careful, the other one. All right, what if the circle is not at 0, 0? So that's the catch. You're not always centered at 0, 0. So I'm going to pick this point here, I'm calling it h comma k, and that's the center of my circle. So I want to find the same idea. So, we can draw the Pythagorean theorem again. Draw that triangle. So let's use that distance formula between here and here, right? So the distance from here to here is distance for x1 minus x2 squared equals y1 minus y2 squared. So what do I have here? H minus k. I'm going to go with x minus h squared plus y minus k squared. That's my distance, right? And if that's d, but that's also r. And if I square this whole thing to get rid of the square root symbol, and I'll just turn it around a little bit. X minus h squared plus y minus k squared equals r squared. And it works for point 0, 0. If h 0 and k is 0, we get back to x squared plus y squared is r squared. So what do you have to remember? hk is your center. X minus h squared plus y minus k squared equals r squared. Let's see it in action. Write a standard equation out for a circle with this center and that radius. Okay, so this is your h comma k. So x minus h squared plus y minus k squared, equals r squared. R is 7. Let's just simplify this down a little bit. So it's x plus 2 squared, because of minus minus, y minus 5 squared equals 49. So you plug these in, and you square the radius. Plug in the center, the x and the y. Remember that you're subtracting, and out it comes. Right, because it's x minus h squared plus y minus k squared. So your x1's going to go here, your y1's going to go here. Just remember that since it's subtracting, it's opposite sign from what you see here. Let's try another one. The point, minus 5, 6 is on a circle with center negative 1, 3. Write the equation of the circle. Let's just draw a picture to see what's happening here. So let's see, the center is at negative 1, 3. And I've got a point on the circle at negative 5, 6. So the circle is like, it's going around this way. I'm horrible at drawing circles. My geometry teacher can draw perfect circles. I can't do that. So I'm really basically, I need to find r, because x squared plus y squared, or x minus h squared plus y minus k squared is r squared. How can I find r? R is the distance from here to here, right? So how do I do that? R equals what? What's the distance between negative 5 and negative 1? 4, and I square that. And I'm just using the Pythagorean theorem again, my distance formula. What's the distance between 6 and 3? 3, I square that. So that's the square root of 25. Oh, that's nice. So my r is 5. So here's my center. X minus h squared becomes x plus 1 plus y minus k squared equals r squared. So if you want to kind of take a shortcut. We don't even have to go to the square root. If I want r squared, I can just say r squared equals, and I use your distance formula. But you don't have to take a square root if you want r squared. Yes?
Would you then substitute the negative 5 for x and 6 for y to solve it?
To solve it, how many solutions are there going to be? How many x, y pairs are going to work? A lot. Not all of them, but a lot. And all those that work are the ones around the circle. So we're not, it's just like, when you have y equals 4x plus 7, right? We don't solve it, it's just describing a set of points. Well, this is also describing a set of points. This set of points makes a line, this set of points will make a circle.
We have 36.
Sure. Yeah. So if you put in a negative 5 and a 6, it's going to work. Right? If you put a negative 5 here, negative 5 plus 1 is 16. Plus 6 minus 3, right? It works. Because it's a point on a circle. And all the points on the circle will work. Yes? Yes! That's it. That's the final answer. We're done. Here it is. Yeah, I know. It's not that big a deal. All right, graph the circle. Now we can work backwards with this, right? Here's an equation of a circle, right? Doesn't it look like x minus h squared plus y minus b squared equals r squared? Let's graph it. First of all, what's the center? And be really careful, because remember, we're subtracting stuff. Yeah. 4, negative 2. Why is it 4, negative 2? X minus h squared plus y minus b squared equals r squared. So you can see how the 4 matches the h, but it's a minus negative 2. That's where we got our plus from. So be careful pulling out the center. So I know where the center is. So I'm going to go 1, 2, 3, 4, 1, 2. Right, 4, negative 2. There's the center. So it's going to be around here somewhere. What's the radius? What is it? What is it going to be? 6. Because this is r squared. If r squared is 36, what's 6? Great. And now we're gonna graph this. So if I know the radius is 6, it's very easy to make 4 of these points. For instance, 1, 2, 3, 4, 5, 6. There's a point on the circle. 1, 2, 3, 4, 5, 6. There's a point on the circle. 2 more that are easy to get. 1, 2, 3, 4, 5, 6. And 1, 2, 3, I can do 1, 2, 3, 4. Hopefully I did that right. I think I got it. And now you can freehand sketch, and I'm horrible at this, especially up here. I'm getting something nasty. Or if you have a compass, measure this, and just zip it around if you have a compass, if you want it to look good, which is horrible. But I will accept a sketch. However, I want to see at least those 4 points kind of plotted there. And it's graphed. You graph the circle. That's it. Let's see, do I want to do this one now? Yeah, sure. The forest range, 3 forest ranger stations are at these different points. So we're going to plot these points here. A is, go ahead and just plot them on your paper. A is at negative 3, 2. B is at 2, 2. And C is at negative 1, negative 1. So these are ranger stations. We're in the forest now. And what do they want us to say? Fire is 2 miles from A. 2 miles from B. Okay. Here's A. If there's a fire 2 miles from here, where's that fire? I don't know exactly, but I can kind of pinpoint it. Because what does that mean to be 2 miles away from a single point? That is a circle of possibilities. Wow, that's a horrible circle. But there's a circle of possibilities where this fire can be, and I'm just having a lot of trouble with it. But, so you make that circle with radius 2 around B, around A. Now B is 3 miles. 1, 2, 3, 1, 2, 3. So basically I'm graphing these circles. I'm graphing them badly, but I'm trying. Oh, horrible. Yours is going to look better. And then 3.5 miles from C. Well, there's a half. 1, 2, 3. 1, 2, 3. 1, 2, 3 and a half. There's a half. 1, 2, 3. Okay, your circles are probably looking a whole lot better than mine. Have we pinpointed where the fire is? If it's 2 miles from A and 3 miles from B and 3.5 miles from C, where is it? Where is it? right here where they're all intersecting. So they intersect at, what is that, negative 3, 2? Oh, negative 1. So we can use this kind of idea of, this is actually called locus. The locus of points that all commune on one spot, and then we can find stuff. So an application of the graphics. Oh, excellent. Yes. Completing the square, remember that? We just reviewed it, didn't we? If you have x squared plus 6x and I want to make this a perfect binomial, perfect square binomial, what is c's value going to be? Yes? 9. How do you get it? Half it and square it. Half of 6 is 3. 3 squared is 9. And remember how do you write this as something squared? X plus 3 squared, isn't it? Right? You want the b square root of that, and this one's signed. So, find c by taking half of b, and then you kind of create this binomial square. So real quick, I want you to complete the square on these guys and write them as binomial squares. You're going to watch me. Can we get A and B relatively easy? This is really the same thing. 5 over 2 squared, you get 25 fourths. And then, isn't that the perfect square binomial? Take the square root of that one. So knowing how to do that is very helpful for what we want to do here, which is putting things in that standard form of a circle. So questions on completing the square. Let's make sure we're okay. The what? Yes, because, right, what's x plus 4 squared? X squared, here's my 8x, here's my 16. Because remember, this, you're going to be multiplying back times that. So it's always going to be the square root, the thing that you created. Take half of b, that's what goes here. Alright, so writing equations of circle. Look at this thing. Write the equation of a circle and find the center and radius. How awesome is that thing? Everybody know where I am because you're going to want to write this down. You all ready to write this down? Okay. So, all kinds of steps. Blah, blah, and blah. That's what you have to do. So let's try it. Okay. So what you do is, you're going to kind of order things a little bit. I want all my x's together. I want all my y's together. Any things that are numbers I want on the other side. So I'm going to rewrite x squared minus 10x. All I'm doing is I'm moving that, using the, I guess that's the commutative property, right? I can just move stuff around. I'm leaving a little space here. Plus y squared plus 8y. I'm leaving a little space. I'm adding 8 to both sides to move this here. Does anybody not get what I just did? Rearranging them. So ask a question if you don't know what I just did. Yeah. Oh, I'll show you that in a moment. So are we okay with this part? I just rearranged. I put the number on the other side. Well, here's why I did that. I want to complete the square on this guy. So you have x squared minus 10x. What am I going to add? What am I going to add? 25. Half of 10 is 5. Square it. Okay? If I add 25 to one side of an equation, what do I have to do to the other side? I have to add 25, right? Have to. Now still in balance. Do the same thing with the y's. Y squared plus 8y plus what makes this a nice perfect square? Take half is 4, add 16. If I just add 16 to one side, what do I have to do to the other side? Add 16 to both sides. All right, now I can write as my nice perfect square there. And here's my other binomial square. What's this one going to be? 1 plus 4 squared. What's 8 plus 25 plus 16? Yeah? 49. Does this look like our standard form of an equation of a circle? Yeah. What's the center? Careful, careful now. What's the center? Yeah, what is it, Sam?
5,
-4. Right? Excellent. What's the radius? Yeah, circle 7. Cool. I think that's neat. You good? No, I do. You try one. Right? Here's a little practice one. Do the same thing with this one. You guys keep working. Don't look at what I'm doing. You keep working. I'm making mistakes. I really don't want to look at what I'm doing. Well, look at your little pen here. Put a match that. What? Well, remember this a minus? That's a minus, right? Because you have a plus 20 here, so it's a minus there. Did anybody get this? Anybody at all? All right, what's the center of my circle? I'm not going to look. And Lydia, what's the center? Excellent. What's the radius?
5.
Right? So I can graph this if I wanted to, right? Yes.
I didn't get 25 because I already did 25
It's a negative, right? Because he was positive here. So when you put him to the other side, he turns negative. So be careful, careful, careful. Yes? How did I get the 6? Because this thing here, right? How